Okay, hello everyone. I welcomes to all in our lecture series on mathematical physics, that is your core paper 8, belongs to 4th semester B.sc Physics Honors CBCS model. In our last class we have been discussed this question number 7, that is your find LS of 1 by 5 minus z into z plus 5 about z equal to 5, one of the singular point of this function, and we found this one. This is the Lorentz series of this function about z equal 5 equal 1 by 100 summation over n equal to 1 0 to infinity minus 1 to the n z minus z0. Here z0 is your 5, z minus z0 or z minus 5 to the power n by 10 to the power n plus whole into minus of 1 by 10 into z minus z0. Z0 means 5, z minus 5 to the power minus 1, and this is your so-called principal part and this is your analytic part. In detail we have been discussed, and I discussed in that class that the coefficient of this one, coefficient of 1 by z minus z0, or the coefficient of z minus z0 to the power minus 1 particularly, is going to be called as the residue of that function about that point. Okay, so here if we are going to consider this series, this Lorentz series or this function about this point, the residue is your minus 1 by 10. These things already we have been discussed, and about the residue of a function in detail we are going to discuss in our forthcoming classes. In this class we are going to discuss another style of a function and we have to find out its corresponding Lorentz series. That Lorentz series of find the Lorentz series of fz equal to 1 by z minus 2 into z minus 3 between the annular region of z equal to 2 and z equal to 3. Okay, so in this question two circles are given. Here z equal to 3 means it is given that z minus 0 mod equal to 2, and here z minus 0 mod equal to 3. So this is the equation of circle, that is your z minus 0, that means the center is at 0, radius is 2. Here for this case center is at 0, radius is 3. We drawn two circles. I told that for each and every Lorentz series numerical, the figure, corresponding figure is most important. And drawing the figure here, it will be help you so much. How it is, you can see. So here you can see in the complex plane, this is your 1 2 3 and so on. This will be your minus 1 minus 2 minus 1 minus 2 minus 3 minus 4 and so on. So here up to this much the radius is your 2, one circle. Up to 0 to this much radius is 3, this is another circle. So annular region means inside this region what will be the Taylor series, so here you can see whenever I am drawing this circle or this circle, what is the center is 0. That means we are trying to find out the Lorentz series of this function inside this annular region about z0 equal to 0. In the question not directly written that about which point we have to find out, the Lorentz series. It is given that the annular region only, but z0 will be required. But z0 is required to find out the Lorentz series of this function. Here for this question, z0 will be the center of these two circles, or the common center of these two circles, because about this point or about this center these two circles has been drawn. Okay, so here I'm going to suggest to all of you that if in the question is not given about which point we have to find out Lorentz series, particularly region based question or annular region based question, then we have to consider that point which is the common center of the circle is the z0. Okay, we have to consider z0 is z0 is that point which is the common center of the circles. So in this particular question we have two circles, the common center is at z0 is at 0. So we are going to consider z0 will be 0 for this particular question. For this particular question z0 will be 0. Okay, suppose we have only one circle and we are going to consider the different regions that we are going to discuss in our next question, like this one. This is only one circle, but we are considering two different regions, outside region and inside region. For this case also the center of the circle will be considered as your z0. Okay, that we are going to discuss in our next question, right? Now, to find out the Lorentz series of this function, first we are going to consider the partial fraction of this function. Here you can see the singular points of this function is your z equal 2 and z equal 3. Now we are going to go for the partial fraction of this function, that is your 1 by z minus 2 and z minus 3. Here I not done all the steps of this partial fraction. I done in the rough. You can see here the partial fraction of this function 1 by z minus 2 into z minus 3 will be equal to 1 by, it can be written as a by z minus 2 plus b by z minus 3. You just add it, it will be a into z minus 3 plus b into z minus 2 whole divided by z minus 2 into z minus 3. And here you can see this will be az minus 3a plus bz minus 2b, and these two terms will be in the denominator. Here you can see this denominator of the RHS will be equal to LHS. So obviously numerator will be equal to numerator of the LHS. That means here you can see numerator of RHS will be this one. Here you can AZ plus BZ. That means A plus BZ, and these are the two terms constants, minus 3A minus 2B. So here coefficient of z is your a plus b, but in the LHS there is no z term. So a plus b obviously will be equal to 0, and this minus 3a minus 2b will be equal to 1, right? Minus 3a minus 2b will be equal to 1. Now just multiply with this equation 2, and then it will be how much? 2a plus 2b equal to 0. So 2b and 2b it got cancelled, and here you can see 2a minus 3a. Okay, 2a minus 3a will be equal to 1. So 2a minus 3a means minus a equal to 1, a will be minus 1. So if a will be minus 1, here you can see a plus b equal to 0 we found. Put a equal to minus 1 here. So b we can get 1. Okay. So by substituting a equal to minus 1, b equal to 1 over here, we can find minus 1 by z minus 2 plus 1 by z plus 3 plus 1 by z plus 3. And that implies 1 by z minus 2 into z plus 3 can be written as, here this term, plus term written here, minus term written here, 1 by z minus 3 minus 1 by z minus 2. Now we are going to go for separately finding the Lorentz series of this one by z minus 3. Then we are going to go for the Lorentz series of 1 by z minus 2. First we are going to find out Lorentz series of 1 by z minus 3. Okay. So here for this case, singular point is your 3, and z0 I told that the common center is your 0. Here singular point is 3 means z dash also will be 3. Here for 1 by z minus 3 we have to find out Lorentz series about z0 equal to 0, which is not, it's a singular point. That means we have to find out its corresponding Taylor series about z0 equal to 0. So C2 not to be considered. Okay. Then Lorentz series of 1 by z minus 3 about z0 equal to 0. In general, we have to consider f1z plus f2z. So as we are not considering C2, circle C2, so f2z automatically it will be 0. Here you can see when we have been proved the Lorentz series, you can see in general the Lorentz series is nothing but your f1z plus f2z. f2z belongs to C2. That means for the inner circle. Okay, for the inner circle C2. But here C2 is not to be considered. So C2 is your, if C2 is not to be considered, so f2z will be 0. The Lorentz series will be only f1z. Okay. Now we are going to find out the LS of 1 by z minus 3, that is your about z0 equal to 0, but in the annular region as shown in the figure. So here what about z0 equal to 0, we have to find out the Taylor series or the so-called Lorentz series, but inside this region, but in the annular region as shown in the figure. From the figure it can be found that in detail I have been written, you just write, in your exam you can omit. Okay, from the figure it can be found that we have to consider out to in. This is your tricks, out to in. Why? Here you can see, where is the z0? This is the z0. So here z dash for this function is your, here, sorry, z dash is your here, z equal to 3, no, 3 means here. So here you are standing, and any point, any arbitrary point, suppose this is a z, any arbitrary point here inside this annular region, and you are trying to move from this point to that point z. I'm going to zoom it for you, it will be better for you. So for this case, 1 by z minus 3 is your singular point. That means here you are standing, and you are trying to move in this annular region, because in the question it has been given that in between the annular region we have to find out the Lorentz series, right? So if I'm going to move inside this region, suppose a point Z is here and I'm moving from this surface on the circumference of this surface, that means Z dash, Z dash, that means this point Z equal to 3 is your on this surface, and moving from this point to this point means out to in situation. So here out to in situation. So out to in where I'm moving, from where I'm moving, I'm moving from Z equal to 3. So this Z equal to 3 is nothing but your Z dash. Got it? Okay. Okay, same thing. Now f1z means here this f1z will be considered um, as out to in case, out to in, outside to inside, outside to inside, out to in. So 1 by z minus 3 will be written as 1 by out to in means z dash minus z0 minus z minus z0. So z dash is your what? Is your 3 we found. Okay, yes. So z dash is nothing but is your 3, 3, and z0 is your 0, z0 is your 0 minus z0 is your 0. Now here I just you consider this much only, 1 by z dash 3 z0 0 minus z0 0. Now you just check this much is equal to given function or not, 1 by z minus 3 or not. Here you can see 1 by this will be 3 minus z, 3 minus z is not equal to 1 by z minus 3. 3 minus z is not equal to z minus 3. Then what I have to do, that it will be z minus 3 if I will multiply the minus. So this 1 by z minus 3 written in this format by considering out to in case, out to in case. So this is your tricks I written over here. See, this is the tricks you can say, but this tricks I extracted from your theorem itself. This tricks is not any assumption or anything you can say, but this one is the procedure what I have been considered or extracted from your theorem itself. Okay. Okay, so here minus 1 is there. So here you can see 3 minus 0 z minus 0. I told that you should not open this bracket. Suppose here instead of 0 some number will be there, no, so we should not open this bracket. But if it is 0, then we can write z minus 0 as z. So I told that up to this much, after doing up to this much step, what is the first term? You just take common. Here is the first term and this is the second term. From these two terms, first term taken common. Okay. So here the first term is your 3. See, minus 1 by 3 minus 0 minus z minus 0 can be written as minus 1 by 3 minus z. So here is the first term is your 3. Second term is your z. Take 3 as common from these two terms. So if I will do so, then minus 1, 3 I taken common, 1 minus z by 3. So this will be written as minus 1 by 3 into 1 by 1 minus z by 3. Here you can see that z by 3 is always less than 1. You can check by considering any number. This is the arbitrary number, no, arbitrary point z. Z can be here, can be here, can be here, can be here, or anywhere in the region. Okay, so suppose I am going to consider any 1.2.1, 2.1, suppose just above 2.1. If I consider 2.1 by 3, also less than 1. Here z just below 3, that means suppose you are going to consider 2.9, 2.9 by 3 also less than 1. Got it? So z by 3 is less than 1. I told that if 1 minus x format is there, then it will be written as how? Just we have been discussed. If 1 by 1 minus format is there and x is less than 1, then it will be written as in this format. So instead of x, here it is z by 3, which is less than 1. So what we have to write? So 1 by 1 minus z by 3 will be written as summation over n equal to 0 to infinity z by 3 to the power n. Instead of x, we have to write z by 3. So Lorentz series of 1 by z minus 3 about z0 in the given annular region. Here is the condition, in the given annular region. for this question, this is the annular region, will be equal to minus 1 by 3 into directly I written the series of this function will be how much. If z by 3 is 1, the direct we can write n equal to 0 to infinity z by 3 to the power n, right, to the power n. Now we are going to find out Lorentz series of 1 by z minus 2 for this case. For this case, singular point is where z equal to 2 and z0 is your 0, and here z dash will be considered as 2. Why it is? As z dash here we consider as 3, similarly here z dash also will be equal to 2, right? Z equal to z dash, z equal to is the singular point, will be considered as 2, because here this is the circle, here you are standing and you are trying to move inside this region, means what? Inside to out, into out situation will be there, and where you are moving, no, that point will be treated as z dash. Same type of things or same type of work we have been already done in our previous questions. Here if I am going to consider this question, suppose last video question, here we are moving, from this point. This is the singular point for this function z plus 5, means minus 5 is the singular point. From here moving inside this region means z dash is minus 5. So here for C1 case it is infinite, so infinite treated as z dash, and here for this case z dash on this circumference of C2, where C2 is, radius is very small, so C2 coincide with the Z0, so Z dash from where we moved, no, to the region, to the given region, that point is treated as, considered as Z dash. If I will consider this numerical also, here this is the singular point because Z plus 5 is there, that means minus 5 is the singular point. From here I am moving inside this region, so Z dash is your minus 5. And if I am going to consider this numerical, here z equal to 5 is the singular point, so singular point is here, so that singular point is treated as z dash. So singular point is basically considered as the z dash. Okay, now for this case, z dash, where it is, z dash is at, wait, also z dash equal to 2. Okay, z equal to 2 is the singular point and that is considered as z dash, and z0 equal to 0. So from the figure it can be noticed that this is the case of your in to out, because here you are here and moving some extra distance in the complex plane. Complex plane means in to out situation, okay. So here you are outside and coming in, here inside to out, inside out situation, so in to out situation. So in to out and out to in, this language here I introduced and told that this is one type of tricks. Okay, you just remember that this procedure, and these tricks I extracted from your theorem, right? So in to out situation, this case, for this case, that is your 1 by z minus 2 into out case. So into out case means what we have to write, 1 by z minus z0 minus z dash minus z0. Same thing I have been written, 1 by z minus 2 will be written as 1 by z minus z0 minus z dash minus z0 format. We have to write z equal is the arbitrary, written z0 is your 0, written over here z dash is nothing but 2 minus 0. Here you can see, here if 0 will be not there though, so we should not open this bracket, but 0 is there means we can write z minus 0 as 2. Okay, that means second term exists, first term is your z, and second term is your 2. So I told that what will be the first term, that you are going to take common from these two terms, most important. So here the first term is your z, we have to take common from these two terms, and we can found that ls of 1 by z minus 2 about z0 equal to 0 in the given annular region will be equal to 1 by z I taken common from these two terms. So we found that z into 1 minus 2 by z. Okay, here 2 by z for this case always less than 1. Okay, so 1 by the, see, this will be 1 by z into 1 by 1 minus 2 by z will be equal to 1 by z into, as this one 2 by z is always less than 1, so 1 by 1 minus x format it has been written now. So if x is less than 1, we have to write in this format. So instead of x, here it is 2 by z. So we have to write summation over n equal to 0 to infinity 2 by z to the power n. And here 2 by z is always less than 1. If you want, you can check itself. So z is any point. So here you can see, here is the 2 value, and z is any point. Suppose you can consider this point, just above this point, 2.1. So 2 by 2.1 less than 1. Here obviously it will be less than 1. So here this will be suppose 2.9. So 2 by 2.9 also less than 1. So 2 by z here always will be less than 1 in this region for this case, 1 by z minus 2 case. So only for that 1 by 1 minus 2 by z will be written as 0 to infinity summation 2 by z to the power n. Okay. So here you can conclude one thing, that by doing this figure, by considering this procedure into out to in, what you are going to take common, you should not be bothered about that. What will be the first term that you are going to take common, automatically it will be in this format automatically, and you have to just write in the form of 1 by 1 minus or 1 plus x. So here instead of x we have 2 by z, so it will be summation over, the series will be summation over n equal to 0 to infinity 2 by z to the power n. Now we found that ls of 1 by z minus 2 about z0 equal to 0 in the given annular region is this one, and ls of 1 by z minus 3 about z0 equal to 0 in the given annular region this one. But we have to find out the Lorentz series of the function, this one, in the given annular region. In this given annular region, that means we have to find out the Lorentz series of this function. Okay. Here we found the Lorentz series of 1 by z minus 3 equal to this much, this value, and Lorentz series of 1 by z minus 2 is this value. Now we are going to just write, instead of 1 by z minus 3 we have to write this much, this value written over here. Instead of 1 by z minus 2 we have to write this value, I haven't written over here. Okay, so you can write this one in the expansion form also. In the expansion form we can write the LS of 1 by z minus 2 into z minus 3 in the given annular region is, here you can see minus 1 by 3 is there. If I will expand it, so if I put n equal to 0, then something to the 0 will be 1, then z by 3 to the power 1 plus z by 3 to the power 2, like that, z by 3 to the power 1 plus z by 3 to the power 2, and so on. Then second expansion is your put 0, n equal to 0, it will be 1, then this will be 2 by z to the power 1, 2 by z to the power 2, like that. So here it will be 1 by z already is there, 1 by z whole into this series. That means 1 plus 2 by z plus 2 by z square, and so on. And this minus I taken inside this bracket, and we have to put plus. This will be minus 1 by z multiplied with this one. This will be minus 2 by z square, minus 1 by z multiplied with this one, minus 2 square, this z, this will be z square, z cube, and so on. So here you can see that this is your what, analytic part, and this is your principal part, because if I am going to compare our general Lorentz series means analytic part is some coefficient z minus z0 to the power n, z minus z0 to the power minus n, the principal part. So here you can see this one is in the form of what, minus 1 by 3 you can multiply, and we can get the coefficients, each and every coefficients. And here you can see instead of z we can write z minus z0 itself, z minus z0, here z0 is your 0 by 3 plus z minus z0 square by 3, z0 is your 0. So as z0 is your 0, so I not written over here, only we have been written as z minus z by 3, z by 3 whole square, z by 3 whole cube, like that. Here z minus, here 1 by z minus z0 we can write, and here we can write also minus 2 by z minus here z0 means 0 we can write, 0 square we can write. So as z0 is your 0, we not written that one. Okay, I not written this one, z0 I not written, so in this format I written. So here you can see that in the principal part we found infinite series. It will be continue up to n equal to infinite. And here 1 by z minus z0 coefficient is your what? -1. This term is nothing but 1 by z minus z0 and its coefficient is minus, that means -1. So if this question, in this question it is asked that just you have to find out the residue, then residue of this question will be how much? -1, because the coefficient of 1 by z or 1 by z minus z0 is -1, and the principal part is a infinite series. But previously we found in this question the principal part has only one term. You can check the previous video, principal part is only one part, but here principal part is a infinite series. Why I'm telling that? If a principal part will be infinite series, then what is the name of the singular point? If the principal part have only one term, then what will be the singular point name? That we are going to discuss in our forthcoming classes. But here we found the Lorentz series of this one in the given annular region is this one. Either you can write in the expansion form or this form. Okay. For next question, that is your question number 9. Find Lorentz series of the function fz equal to 5 minus z. First bit is your z mod greater than 5. Second bit z mod less than 5. These are the two ranges. This is one question, this is another question. So separately we are going to solve. For this range we are going to solve, and for this range separately. Okay. So here you can see that the given function is your 1 by 5 minus z. And for this function, clearly z equal to 5 is the singular point. So singular point of this function is equal to 5. If I will put z equal to 5, so it will be 0. That means could not be defined. So singular point of this function is 5. Okay. As I told that if in the question it is not given about which point we have to find out the Lorentz series, then you have to consider that point is your 0. So here z0 equal to 0. Now we are going to draw the figure for this range, that is your z mod greater than 5. Okay. So here z mod greater than 5 can be written as a circle equation. Here you can see, given that z mod greater than 5, okay, z mod greater than 5 it has been given. So this can be written as z minus 0 mod greater than 5. Okay. So here if we are going to consider z minus 0 mod is equal to suppose 5, then what will be its diagram is your what, like this. This is your 1 2 3 4 5. 5 is the 5 will be the radius, and this will be the center is at 0, and 5 will be the radius. This will be the 5. Okay. If z minus 0 equal 5 has been given, but here it has been given that z minus 0 greater than 5. Greater than 5 means we have to consider those region of the circle which is above this circle. That means this is circle having the radius is 5. So this is the circle, but in the question it has been given that the region we have to consider, that is your z minus 0 greater than 5. 0 is the center. This is the circle having the radius is your 5, but the region is above this 5 radius. We have to consider the region. Okay. So same thing it has been written that this in short I have been written, these things I not written, that if we are going to consider this z mod greater than 5 in circle equation, so z minus 0 equal greater than 5, this is in the form of circle equation. Okay. Circle equation means z minus 0. Here 0 is the center. If I will consider 5 is the radius, then this will be the circle. Okay. Here you can see 1 2 3 4 5. So this is the point 5, and the radius will be this much 5, and this is the circle having the radius is 5. But as per the question, we have to consider the region above that 5. That means this region. So for first bit, we have to find out the Lorentz series of this function 1 by 5 minus z for this region. That means z mod greater than 5. This region also can be found by considering the mod function. Here it has been given that z mod greater than 5. Okay, so by considering the mod function, here z mod greater than 5 means z greater than 5 and z less than minus 5. So if we are going to consider, here you can see z greater than 5. Z greater than 5 means from this point to onwards, this side greater than 5. Z less than 5 means from this point, this is your minus 5, right? This point is your minus 5. Less than minus 5 means this side. Okay, so this will be the range above plus 5, below minus 5. So here I drawn in the circular method or circle method. So I suggest that you just consider this circle method, it will be easy for you. Okay. Likewise, if in the mod function it has been given that z mod less than, suppose less than 5 it has been given, that is your second case. Okay, when z mod less than 5, z mod less than 5 means what is the range is your minus 5 to 5, minus 5 to 5. That means z will be in between minus 5 to 5, that means inner region. Okay, so for the first bit question, when z mod greater than 5, we have to consider the outer region of this circle. When z mod less than 5, we are going to consider the inner region, because z mod less than 5 means the region is your minus 5 to 5. And for z mod greater than 5 means z is to be considered z greater than 5, and z less than 5 means above this 5, below this minus 5. That means we can say this outer region. Got it? Okay, so I suggest that you just practice to find the region or range by considering the circular method, this circle method. Next question we are going to do with this circular method, circle method. You will be clear about that. Okay, now here we found that this is our outer region. That means when we are going to consider this z mod greater than 5, outer region means this region we are going to consider. So here singular point of this function is your 5, about which point we have to find out z0 equal to 0, z0 equal to 0. That means about singular point we are not going to find out the Lorentz series. So here if we are going to target to move into this region, into outer region for this function, that means where you are standing at z dash equal to 5, z dash equal to 5, which is the singular point. So here you are standing and you are trying to move outside of this region, or outside, you are just moving outside. That means this is in the case of into out case, into out, which is your tricks, into out motion. Okay, z dash is your singular point. You are standing over here and you are trying to move this outer region, because as per the question it has been given that we have to consider the Lorentz series of this function for this one. That means z mod greater than 5 means for outer region. So outer region means z dash will be what? Z dash will be, it's a singular point. The singular point is 5. So you are standing over here. Okay, I'm going to just zoom somewhat. You are standing over here and you are moving outside. That means into out motion. This is one tricks you just remember. And I several times I told that these tricks I have been derived from the Lorentz series theorem. Okay, now if this is the case for into out, then the function 1 by 5 minus z, 1 by 5 minus z will be written in this format, because into out means what is the general form? 1 by z minus z0 minus z dash minus z0. Same thing it has been written, z minus z0 minus z dash minus z0. So here 1 by 5 minus z will be equal to, here you can see first you just consider z0 and z dash. Here z is the arbitrary, z0 is your 0 minus 5 minus 0. Now you just check that here, now you just check that this much is your original function or not. Here you can see that 1 by this will be z plus 5, right? This will be z plus 5. Sorry, this will be z minus 5. Here you can see this will 1 by z, here minus z minus 5. But our original function is your 1 by 5 minus z. So what we have to do? We have to just multiply another minus. Now it is going to be equalized. Many times I told to you that you found where in which type of motion is there, in to out or out to in. You just write in that format. then you just check that it is exactly matched with the original function or not. If it is matched, then no problem. It is not matched, then you just multiply the minus. Then what you have to do, then what will the first term, here you can see this is the first term, this is the second term, and I told that you do not remove this bracket, do not remove this bracket, but as it is 0 you can remove this bracket, no problem. But this is your first term, this is your second term. Here I have been written by removing the 0. So what it is, this is minus 1 by z minus 5. Okay, now here that implies 1 by 5 minus z will be equal to minus 1. I told that first term is going to take in common from these two terms. If I'll do so, then z into 1 minus 5 by z so this will be minus 1 by z into 1 by 1 minus 5 by z. Now this is, if I'm going to consider this one, then 5 by z will be always less than 1 in this region. How it is, you can check. Say suppose you consider this point, this is your 5, this is your 6. So if I'm going to take z, so for the simplicity you just consider the z point is here at 6. Okay, so if I'm going to put the 6, then 5 by 6 is less than 1. You just consider 5.1 here, just above the 5 point. So if I'm going to consider 5 plus 5.1, then 5 by 5.1 also less than 1. So as this one 5 by z is less than 1, then this series of this function 1 by 1 minus this one, which is less than 1, will be written as 0 to infinity summation 5 by z to the power n, because we know that 1 by 1 minus x series is nothing but summation over n equal to 0 to infinity x to the power n. And also we know 1 by 1 plus x series is your what, n equal to 0 to infinity minus 1 to the n x to the power n. But here x condition is x is always less than 1. These things already we have been discussed in Taylor series and Lorentz series also. Okay, in detail at that time we have been discussed. So I suggest that to do the Lorentz series, these two basic expansions you have to remember: 1 by 1 minus x expansion, or you can say Taylor series is your this one, and this for this one equal to this one. For plus, this will be minus 1 to the n minus only x to the power n summation n equal to 0 to infinity for both the case. So here you can see this is 1 minus 5 by z. 1 minus x means x to the power n. So instead of x, what we have to write? 5 by z to the power n. So this is the Lorentz series of the function 1 by 5 minus z in the given region. That means for outer region. Now we are going to consider z mod less than 5. As I told that if we are going to consider the mod function, then what is the range? Minus 5 to 5. That means in between minus 5 to 5, right? But I suggested that you have to just consider the circular equation format. So this z mod less than 5 can be written as z minus 0. This is a circle equation. So here you can see, if I am going to consider z minus 0 mod equal to 0, equal to 5, then this will be the circle having the radius is your 5, because here for this circle equation 0 is the center and 5 is the radius. Okay, 0 is the center, 5 is the radius. So for this case we have to consider those region which is less than 5, because in the question it has been given that we have to consider z mod less than 5. That means if z minus 0 will be equal to 5, then we are this is a purely circle equation. But as it is given that less than 5, that means we have to consider this inner region. So okay, inner region. So here you can see for this function 1 by 5 minus z, where is the singular point? Singular point is at 5. So from here you are standing here. Okay, you are standing here and you are trying to move inside this region to any point. Suppose that means what is the situation? Situation is out to in situation. Here I written out to in situation, but for this case it was in to out. See, here you are standing at 5, you are moving inward. For this case, for first bit case it was moving outward, but this one is your moving inward. So this case is your out to in case. So here out to in motion, that is your tricks. I told that in to out to in is one type of tricks what I have been derived from the theorem. So here in this case z dash will be your minus 5, z dash will be your 5 and z0 is your 0. Now 1 by 5 minus z will be written as, if out to in case 1 by z dash minus z0 minus z minus z0. In that format we have to write. In general I written 1 by z dash minus z0 minus z minus z0. Z dash here 5, z0 is your 0, z is your z, z0 is 0. So now here you can see that I told that this will the first term, this will the second term, but after this step you just match. Is it is matching with the initial equation or not? Here you can see 1 by 5 minus z. Here also 1 by 5 minus z. It exactly matched, so no need to multiply minus. As such I lived. Here you can see I told that do not remove this bracket, second bracket do not remove. So here as it is 0 we can remove, but we found first term and second term. So third step is that you just take the common whatever you have the first term. Here what is the first term? Is 5. Take common 5 from these two terms. It will be 5 into 1 minus z by 5. So 1 by 5 into 1 by 1 minus z by 5. If you are going to analyze, you can find that z by 5 will be always less than 1 in this region. Z by 5. You are moving from this point to this side, no? So for the simplicity, you just consider z is along this axis. So here you just consider this z is at here. That means at 2. So 2 by 5 is less than 1. Here suppose 4. 4 by 5 also less than 1. And here you can see just below 5. That means 4.9 suppose. Z you just consider 4.9. 4.9 by 5 also less than 1. So here I written clearly Z by 5 for this region always less than 1. If it is so, then what will be its series? Directly we can write that summation over n equals 0 to infinity z by 5 to the power n, because here already we have been discussed 1 by 1 minus x will be x to the power n summation over n equals 0 to infinity. So for this case, instead of x it is your z by 5. So this is the Lorentz series of 1 by 5 minus z for this region, or your outer region. For outer region will be this much, for inner region will be this much. Got it? Okay. In this question we got a interesting result. What is that? I'm going to show you. See, for the first bit, that means for z mod greater than 5, ls of 1 by 5 minus z, what we found? This one. Okay, you just analyze this one. This can be written as here 1 by z summation over n equal to 0 to infinity 5 by z minus 0 to the power n. That means z minus z0. We can write z minus z0. If we are going to consider general form of Lorentz series, that is nothing but sum of analytic part and principal part. Analytic part means z minus z0 to the power n, but principal part means z minus z0 to the power minus n. If I am going to consider the Lorentz series of this one in this region, in this region, we not found analytic part, only we found the principal part. Here you can see 1 by z is there, or you can write z minus 0 or z0, and here 5 by z minus 0 to the power n. If I will be expand it, it always denominator. In the denominator we can found the z minus z0. That means this format terms we are going to get. But z minus z0 to the power n, that means positive power of z minus z0 is absent in this series, whole series. That means for this case, the analytic part is absent, only principal part is present. Okay, got it? So which case? For z is greater than 5, z mod greater than 5. For z mod greater than 5, what we done? We done into out case, into out. Got it? If I'm going to compare our previous question, here you can see this is our previous question, that we have to find out the Lorentz series of this function. That means we have to find out the Lorentz series of 1 by z minus 3 and 1 by z minus 2. For Lorentz series of 1 by 2, at the time of finding Lorentz series of 1 by z minus 2 about z0 equal to 0, corresponding singular point is your 2, or z dash equal to 2, what we done? Here you can see we moved from in to out. That means this is your in to out case. Okay, here in to out case. For this case particularly, what we found? We found only principal part, right? But in case of out to in case, that means for 1 by z minus 3 case, that is your out to in case, we found analytic part only. Just remember, this is another result or one type of tricks you can say. So where you have to use out to in means there you are going to get the analytic part. Where you are going to use in to out means there you are going to get the principal part. That means negative power and positive power, analytic part, principal part. So here in this case we consider in to out motion or in to out case for z mod greater than 5, and we found only the principal parts and analytic part is absent. Consider out to in case. Out to in case, here we found z by 5 to the power n, or we can write z minus z0 to the power n by 5. There is no principal part. That means positive power of z minus z0. And in this case, in case of principal part, we can get the negative power of z minus z0. So when we are going to consider in to out, there we can found only the principal part. When out to in case, we can get the analytic part. This is your principal part. In to out, out to in. Okay, so you just remember it. It is very useful for different type of numericals. Here we are going to stop our today's class. In the next class we are going to discuss another important question, that is your question number 10. Find LS of fz equal to 1 by z plus 3 into z plus 5 in this region, that is z mod less than 5, z mod greater than 5, and third bit is your z mod in between 3 and 5. Thank you so much for watching this video. Thank you.